In this video, I will be going over the order of operations and some properties of real numbers. First, let's do the order of operations. Everyone always remembers PEMDAS. That doesn't really make sense to me, so I remember it as please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. Now, multiplication and division and addition and subtraction kind of fall under the same category, so you could just say PIMA. Please excuse my aunt. Still makes sense. And yeah. So you might get a problem like this, where the instructions are just to simplify. Notice there's no equal sign. We're not solving for anything. There's no variables either. It's just, we want to take this complicated mess of numbers and make it simpler, or simplify it. That's why they say simplify. So what do we do first? Well, parentheses. So there's parentheses here, and we're doing two things in these parentheses. We're doing subtraction, and we're doing a power. We're raising it to the power of 2. Power is also known as an exponent. So you'd think we do the exponent first, right? No, we actually do the subtraction first. I thought subtraction was the last step here. No, it's whatever's inside the parentheses. It doesn't matter what it is. So right off the bat, we already have exceptions to the rules, but it isn't really an exception. It's just 6 minus 3, 3. Now we square it. Okay, well, the next step is exponents, right? Well, you know there's one exponent, 3 squared. What if I told you there's another exponent here? That's right, roots are also exponents. Writing square root of 4 is the same as writing 4 to the 1/2 power. A root is just a power as a fraction. It's between 0 and 1. So square root of 4 is 2. Okay, well, that was easy. Next, multiplication. We can do that. Only one multiplication problem here. 9 plus 3 times 5, 15. Okay. Division, can't really do the division. 2 does not go into 15 exactly. 15 is an odd number, so can't divide it by 2. So we've found yet another exception to the rule. We can do addition before division. It's just, that's an improper fraction. So we can't divide it out neatly. So we're going to have to do the addition first. Well, adding fractions, you got to find a common denominator, right? So, because this isn't expressed in halves, it's expressed in one whole number, you know. So we need these two numbers to be the same. So how do we do that? We just multiply it by 1. 2 over 2 is 1, right? Yeah, 2 times 1 is 2. 2 times 9, 18. And there we go. Not done yet. 18 plus 15. And just do it this way just to make sure I get it right. 8 plus 5. 13, right? Carry the 1. 1, 2, 3. 33. Yeah, sounds about right. So 18 plus 15 is 33. Denominator stays the same. You don't add those together. That's just telling you the denominations of them, you know? 33 over 2. Now, you could say that's your answer. Sometimes a teacher might ask you to leave your answer as an improper fraction. There we go. We just did it. Sometimes they'll ask you to convert that to a mixed number. How do we do that? Well, we got to do some long division in order to do that. 33, the numerator, divided by 2, the denominator, right? 2 goes into 3 one time. Carry the 3 down. 2 goes into 13 how many times? 6 times. Okay, now we have 1 left over. So we say remainder 1. So the mixed number would be 16 and 1/2. 16 and a half. Improper mixed. It's not 16 times 1/2. It's 16 and a half. If we meant 16 times 1/2, we would have put a little multiplication dot in there, but it's 16 and a half. All right. That's the order of operations. And I have another example, though. It's always good to practice your order of operations. Okay. Here's another one. Simplify. Now, this is not parentheses, it's absolute value. But it falls under the same category. Absolute value. And later on, just to cover all of our bases here, exponents might also consider logs part of the exponents step, but I want to double check me on that one. But logs are dealing with exponents, so anyway, want to do that absolute value first. 3 minus 7. So you get a positive 3 minus 7. So we actually get negative 4, the absolute value. Square root of 36 plus 15 over 6. And you can also do 2 steps at once, you know, because this isn't going to affect that very much till later. You could actually say, oh, square root of 36, that's just 6. Might as well get it done. Absolute value of negative 4. When we're taking the absolute value of something, we're asking you how far is it from 0. So 0 is here. Negative 4 is down here. positive 4's down here, over there. They're equally distant from 0. But that's just a complicated way of saying we just want the positive of whatever negative is in there. So it's just 4 squared over 6 plus 15 over 6. 4 squared is what we do next because it's an exponent, right? 4 squared is 16. 16 over 6 plus 15 over 6. Again, except we don't have to find the common denominator this time because it's already there. Nice and neatly packed for us. 16 plus 15 is 31. Just have to trust me on that. And there's your answer. And once again, we could make that a mixed number. And that would be 5 and 1/6, right? 6 goes into 30 5 times. 6 times 5 is 30. 5 and 1/6. Also correct. All right. Now let's go over some properties of numbers. Kind of exceptions to the rules here, you know. And I hope you wrote all that down because I'm erasing it. Most of it. Still got PEMDAS up here. There we go. All right. First property is commutative property. When adding and multiplying, order doesn't matter. That's what it means. 3 plus 7 is the same as 7 plus 3. That was the easiest property I'll ever know. Also, 4 times 6 is the same as 6 times 4. Wow. Who knew? But that only applies to addition and multiplication. Division, order matters. Definitely matters. Subtraction, order definitely matters. Exponents, parentheses, yeah, order matters. All right, next property. Well, let's just say order doesn't matter for addition and multiplication. Okay. All right, next one, associative. And this is just saying grouping. Doesn't matter. Also doesn't matter. And what they mean by that is, well, if you put parentheses here with addition, it's the same as putting parentheses over there. And it's also the same as doing 3 plus 2 first. Let's just check that, right? 7 plus 2, 9 plus 3, 12, right? 3 plus 7, 10 plus 2, 12. 3 plus 2, 5 plus 7, that is also 12. See, doesn't matter. Same thing, addition and multiplication only. That's why I love multiplication. Just does not matter which order you do it in. So you can do 3 times 4 times 8. You can do that. You can do 3 times 4 first, and then times 8, and then you can do 3 times 8 times 4. All get you the same answer. What is 12 times 8? 108? No. I have no idea. I need a calculator for that one. 12 times 8. 2 times 8. 16. 8 times 1 is 8. Plus 1 is 96. Okay. So yeah, 4 times 8, 48. No. 4 times 8 is 32. 32 times 3, also 96. 12 times 8, 96. We just did that. 24 times 4, 96. Sorry, I was came up with a problem that I confused myself with. But hey, it happens. So that's the associative property. All right, now there's another property here called the distributive property. Gonna need to know this in algebra. I'm not gonna write out what it means because it's a little too much. It just says product of a factor times a sum is the sum of the factor times each of the two sums. Well, what they mean by that is product of, well, a number times a sum being an addition problem. Could also mean subtraction because technically that's under the same umbrella as addition. It's the same as 3 times 7 plus 3 times 4. This is very important. Now you'd be like, wait a minute, didn't we just go over the order of operations where you could just add these together and get 11? And then 3 times 11 is 33. Isn't that a lot easier than doing this? I'm trying to remember this. Well, 3 times 7, 21 plus 12, 33. This isn't so much important now, but it will be important later on when we get variables added to this stuff. Because we don't know what this number is, we need ways of getting rid of the parentheses, you know? So we multiply 4 times x and 4 times negative 5. 4 times x That's what 4 times x is. It's 4 times x, 4x. 4 times -5, -20. That's all there is to it. But let's make this a little more complicated. Let's actually solve an equation this time. What if they actually set that equal to something? What if they set it equal to 3x plus 12? I'm like, well, Joe, you just said it was 4x minus 20. Wait for it. We're actually solving this one this time. Completely different problem. 4 times x, 4x, 4 times -5, -20. Leave everything on this side the same. Now, solving for x, we need to do the opposite of whatever operation is being done in order to isolate the x. Get x by itself, as a lot of people say. I like to have the x over on the left side of the equation. So whatever we do to one side, we got to do it to the other. Subtract 3x. 3x minus 3x is 0. 3 minus 3 is 0. 0 times x is 0. 0 times anything is 0. So if I subtracted 3x from the right side, I got to do it to the left side, minus 3x. Now, I put it underneath this because it has that x next to it. I'm combining like terms, which I'll get to in the next video. 4 minus 3 is 1x. 1 times x is just x. That was easy. And that was just 12. Because that became 0, right? So it's gone. Now we still have x minus 20 equals 12. So we do the opposite. Since this is negative, we add 20 because we want a 0 here. X plus 0 equals, and since I added 20 to that side, I got to add 20 to this other side. Oh, can't forget that. X plus 0 is just x. So x equals 32. That's why you got to know the distributive property. Now, there's another way to solve this that is considerably more complicated if you didn't know the distributive property. What if we didn't know the distributive property and we tried this again? Well, we could still solve it. It would just be a little harder, much harder. Divide both sides by 4. You got to divide the whole thing by 4 when you're doing multiplication and division when solving equations. 4 divided by 4 is 1. We're trying to get a 1. We're not trying for 0. Because 1 times this is just this, x minus 5. 0 times that would be 0. We don't want 0. Divide the whole thing by 4, we get 3x plus 12 over 4, or 3x divided by 4. That doesn't look like an x. Plus 12 over 4. Except technically I just used the distributive property again. I just distributed a fraction over 3x plus 12. I wanted them separated because that's the only way to get x by itself now. Say 1/4 times 3x is 3x over 4. 1/4 times 12 is 12 over 4. That's how I got this. 12 divided by 4, that's just 3. That was easy. Now we got to get this over here, right? So we got to subtract 3x over 4 to get a 0 there. So now we have x minus 3x over 4 minus 5 equals 3. Wow. Whoosh. Common denominator, 4 over 4. That was easy. 4 minus 3, 1x, x over 4. And we can also move this over, add 5 to both sides. We get 0 here, 8 over there. X over 4 equals 8. Multiply both sides by 4 because we want to get 1. 1 here again, right? 4 over 4 would be 1. So x equals 8 times 4, which is 32. So we could still solve it, but wasn't that much easier when we distributed that 4? Instead of distributing a 1/4 over here. Oof. So there are different ways to get the same answer in math. All right. And just a couple more properties, and then we'll be done with this video. Very simple properties. Kind of ones that I kind of touched on just now in this problem. Identity properties. There's the identity property of addition. 0 plus anything, 163, is still 163. That was easy. An identity property, also 163 multiplied by 1, that's the identity property of multiplication. Anything multiplied by 1 is still the same thing, which I kind of touched on earlier. You could easily say any number being x is also just x. Any number being x is also x. And I'd also like to add something to this. Anything raised to the power of 1 is also that. So identity property of exponents. I didn't see that in the book, but still true. And also, one last property, inverse property. Inverse property means anything minus that same thing will get you 0. Anything multiplied by 1 over that something gets you 1. Also demonstrated in the problem I did earlier. And those are the properties you need to know before college algebra.